Let's look at some more homework problems from section 5.2. Now these next two, 31 and 35, involve these new trig integral rules that we learned. So if you look at this form, cosecant of 2x dx, this is in the form of cosecant of u du. And if we recall, we have a specific rule for cosecant of u, which is negative natural log, absolute value of cosecant of u plus cotangent of u. So if we're trying to match these forms up, then it should be apparent that we want to go through u substitution with our u value being 2x. So we let u be 2x, derivative is 2, dx is simply du over 2. We make our substitution, 2x gets replaced with u, du over 2, dx gets replaced with du over 2. We pull the 2 out as 1/2 to keep track of the coefficient. Integral of cosecant of u is simply negative natural log, absolute value cosecant of u plus cotangent of u plus c. And we want to make sure we hold on to the 1/2. And now write our general solution in terms of x. Okay, 35. We have the integral of secant tangent over secant of x minus 1. We want to identify the u value in this case. We don't have a rule with this form. But if we let the denominator be secant of x minus 1, if we think ahead, then the derivative of secant should cancel out with this numerator, which is the derivative form of secant. So let u value be secant of x minus 1. The derivative is secant tangent. Derivative of secant is secant tangent. 1 is a constant, goes to 0. Solve for dx. dx is du over secant tangent x. We make our substitution. The denominator gets replaced with u. Dx gets replaced with du over secant tangent. So now we're left with something that can cancel out nicely. So we have integral of 1 over u du. We can go through natural log of u to find the integral here. So natural log of the absolute value of u plus c. And now the u gets replaced with secant of x minus 1. All right, 37, solving differential equation. We've seen these problems before. We're just trying to bring the derivative function back up to the original f of x function. So we have our dy over dx equals 3 over 2 minus x. First step with solving differential equation, we go ahead and get the y's on one side, everything else on the other. So dy stays on the left. On the right side, we have 3 over 2 minus x dx. Take the integral of both sides. We know the integral of dy will turn into y. The integral of 3 over 2 minus x, we can apply the appropriate rule. In this case, we can go through u substitution. 2 minus x becomes replaced with u. The derivative is negative 1, so dx is negative du. Okay, we make our substitution. Integral of 3 over integral of 3 times integral of 1 over u times negative du, which becomes negative 3 integral of 1 over u. And integral of 1 over u is simply natural log of u, absolute value of u. U gets replaced with, in terms of x, so we know the u value is 2 minus x. So we replace u value with 2 minus x. So now we have the general solution for y. Okay, but we're looking for a specific solution because they give us an ordered pair that we can plug in. So let's solve for c. Replace 0 in for y. Replace 1 in for x. So we get 0 is equal to negative natural log of absolute value of 2 minus 1. 2 minus 1 is 1. Natural log of 1, if you recall natural log properties, natural log of 1 is simply 0. So 0 equals 0 plus c, so therefore c is 0. Plug 0 in for c, and we have our specific solution, which is negative 3, natural log of the absolute value of 2 minus x. All right, 39. ds over d theta is equal to tangent of 2 theta. Okay, we're trying to find the specific solution at order pair 0, 2. Think of s as the y value. Think of theta as the x value. So we want to get ds, s on the left side, and the independent variable on the right. Take the integral of both sides. Integral of ds becomes simply s. Integral of tangent of 2 theta, we have to think about the fact that we do have a rule for tangent of u. So if that's the case, then we want 2 theta to be our u value. Okay, so u is 2 theta. du over d theta is equal to 2. Solve for d theta, which is du over 2. And so we have the integral of tangent of u times du over 2. Pull the 1/2 out. So the integral of 1/2 times the integral of tangent of u du. And we have a rule for tangent, which is negative natural log of cosine of u plus c. Okay. Replace u back in terms of theta. So we have our general solution. Now replace the theta and the s so we can solve for c. We have the order pair 0, 2. 2 plugs in for s. 0 plugs in for theta. So we get 2 is equal to negative 1/2 natural log of cosine of 0 plus c. Cosine of 0 is 1. Natural log of 1 is 0. So 2 is equal to 0 plus c. So therefore c is equal to 2. Now we go back to our general solution and replace the c in terms of our c value, which is 2.